Alright, we're going to go over partial fractions real quick. So partial fractions is another way of solving integrals that you don't know the integral of off the top of your head. And they're not that difficult to recognize, like to know when to do a partial fractions. But like the only way I could easily tell you is like if you have a function where the bottom, like if it's like in division form, fraction form, and the bottom of it looks like a quadratic, like say x squared minus 6 or something like that, then you know that it has to be, if that's the denominator, like you have something on top like 5 minus x, if that's your top, then you know, and you're taking the integral of this, you know that this has to be partial fractions is the method to use with this. And after a quick example, you'll understand a little bit more about why. So, example problem that we're going to do is the integral of 10 minus x over x squared minus 4. So, to begin with partial fractions, what you should first do is separate the denominator, factor it out to have the two functions. So this is going to be equal to the integral of 10 minus x over x minus 2 and x plus 2. So that will make it easier to do the partial fractions. So after you do this, you're going to set this equal to, you're going to set that equal to the integral of a over the first one, x minus 2, plus the integral of b over x plus 2, which is the second one, is going to be equal to the integral of 10 minus x over x minus 2 and x plus 2. So there, that's the new formula we have now. So for a second, I just want you to forget the integral sign that's in front of each one and think kind of like this. So after you've done that, it's easier to do the method of partial fractions on and solve the equation. So what you need to do is figure out what your a and b are, because if once you figure out what your a and b are, you can plug them back up here and solve for the integrals. So to do that, first you want to get it out of fraction form, and the easiest way to get it out of fractional form is to go here, figure out see what your denominator is, and multiply everything by what the denominator is. So I'm going to multiply everything in this equation by x minus 2x plus 2. And when I do that, I'm going to multiply x minus 2, x plus 2 times a over this. The x minus 2 and the x minus 2 will cancel out and just leave me with a x plus 2. Plus, and the x plus 2 and the x plus 2 will cancel out and leave me with b x minus 2. And the x minus 2 and x plus 2 will both cancel out on this one, so that'll just leave me with 10 minus x. So that's your new equation. So to solve for a and b now, we have to plug in x values to separate and get a or b alone and solve for it. So to do this, you look at what your you have x minus 2 and x plus 2. So first you wanna, if you want to solve for a first, you set your x equal to 2. When you set your x equal to 2, this will automatically become 0. So to the side here, you can just say x equals 2. And then if you plug in 2 into all your x's, you're going to get 4a plus, this is going to equal 0, because 2 minus 2 equals 0, equals 10 minus 2 equals 8. And if you solve for that, your a is going to come out to equal 2. And then you do the same thing for b. So now you want to solve for b. So what do you say your x equal to? You would set it equal to -2 to cancel off the a. So if you say x equal to -2, you would have 0 here, plus -2 minus 2 equals -4b, equals 10 minus -2, 12. And that means your b equals -3. So now that you have what your a and b equal, you can go back up here and plug them in. So we're going to go over to the side and rewrite this. So you have the integral of your a is 2. So the integral of 2 over x minus 2 plus the integral of b, and your b is -3, -3 over x plus 2, and that's going to equal the integral of 10 minus x over x minus 2 x plus 2, which is what we're trying to figure out. So these are two integrals that you can solve, and first, to solve them, you would just factor out your two constants that you have. The first constant is 2, so if you factor that out, you're going to have 2 integral of 1 over x minus 2 plus -3, so -3 times the integral of 1 over x plus 2, and that'll equal the integral of 10 minus x plus 2. So now that you have this, you know the integral of 1 over x minus 2. The integral of 1 over x is just ln of x, and since it's x minus 2, it would be the ln of the absolute value. You have to make sure you put absolute value whenever you're doing integrals of logs. So it'll be 2 times ln of the absolute value of x minus 2 minus 3 times ln of the absolute value of x plus 2. And that, if you can just write this over here, is the integral of 10 minus x over x minus 2 x plus 2, or x squared minus 4. So this is your final answer. So as a quick recap, in the method of partial fractions, you're using partial fractions if you have a quadratic in the denominator. It's going to be fraction form, and if you have a quadratic in the denominator, you're going to use partial fractions for it. And so in this example, we had x squared minus 4, so the first step is to separate the quadratic on the bottom and to factor it out. So we have x squared minus 4 is equal to x minus 2 x plus 2. So now you have the integral of 10 minus x over x minus 2 x plus 2. So what you immediately do after this is separate for each function or factor on the bottom. You set it equal. You set an a or a different letter for it. So since we have 2, we're going to have 2 different letters. If we had 3, we'd have 3 different letters. And so for this one, we have 2. So we have the integral of a over x minus 2 plus the integral of b over x plus 2 is equal to the integral of 10 minus x over x plus 2 x minus 2. So now that you have all that, you can go ahead, like I said, you can just forget the integral sign for just a second and focus on the actual content. And you have a over x minus 2 plus b over x plus 2 equals 10 minus x over x minus 2 x plus 2. And what you first want to do is eliminate your fraction, because you need to solve for a and b. You can't do that if you have fractions. So what you do to eliminate the fraction, you're always going to multiply by what is the denominator on the answer side. The denominator in this case is x minus 2 x plus 2. So you multiply everything in your equation by x minus 2 x plus 2. And when you do that, the x minus 2 is going to cancel out with the x minus 2 here. So that leaves you with a x plus 2. The x plus 2 and x plus 2 here will cancel out to leave you with b x minus 2. And they both cancel out here to leave you with just 10 minus x. So with that being said, you now need to solve for your a and b. And it's in simple form to solve. You just need to set values for x. So when you're setting values for x, again, you need to look at it and try to set one of them equal to 0, or your a or b, to solve for the other one. To leave it, set it alone to solve for the other one. So to do that, if we want to solve for a, to set b equal to 0, we have to set x equal to 2. So if we set our x equal to 2, we're going to get 0 here. We're going to get 4a here, and we're going to get 8 over here. And then that easily solves out for a equals 2. We'll do the same thing when we're solving for b. We set x equal to -2 to cancel out the a. We'll get -4b, and that's going to be equal to 12. And so b is going to be equal to -3. So once you have that, go back up to your integral equation. This is when you start remembering and putting back the integral signs. And you have the integral of 2, which is what your a was, over x minus 2. And the integral of 3, or -3, because that's what your b was, over x plus 2. That is going to be integral to the integral of 10 minus x, x minus 2, x plus 2. So, that being said, your 2 and your -3 are just constants, so you can factor them out and put them on the outside of the integral. So now you have the 2 times the integral of 1 over x minus 2, plus -3 times the integral of 1 over x plus 2. And this is an integral that you know how to solve, because it's 1 over x, the integral of that is just ln of x, ln of the absolute value of x. So that being said, you can the integral of 10 minus x over x squared minus 4 is just going to be equal to 2 times the ln of absolute value of x minus 2, because we're doing the integral, it would be absolute value. And so it's going to be 2 times the ln of absolute value of x minus 2 minus 3 times the ln of absolute value of x plus 2. And that would be your final answer. And that is a simple way of doing partial fractions.